Hello everyone, you are welcome to today's class. Our topic today is equation of a straight line graph. A graph obtained from a physics experiment can either be a straight line or a curve. In today's lesson, we will focus on straight line graphs. As explained in the previous lesson, when you plot experimental data, the point may not lie exactly on a straight line. This is because of random errors which are unavoidable in any experiment. However, the points that do not lie exactly on the line should be symmetrically distributed on both sides of the line of best fit. The equation y is equal to mx plus c is the general equation for any straight line. Here m represents the gradient or slope of the line and c represents the y-intercept, which is the point where the line crosses the y-axis. The coordinates of any point on the graph are written as x for the horizontal axis and y for the vertical axis. Let us consider an example. F is equal to ke from Hooke's law, where f is the force, e is the extension, and k is the force constant. If we plot f on the y-axis and e on the x-axis, we obtain a straight line graph. This equation is identical in this form to y is equal to mx plus c, f is equal to ke, where y is equal to f, x is equal to e, m is equal to k, the gradient or slope of the graph, and c is equal to 0. In theory, this straight line is expected to pass through the origin. However, you should never force your line to pass through the origin because due to random experimental errors, the line may not pass exactly through the origin. Now, consider the situation where e is plotted against f. To obtain a straight line relationship, we rearrange the equation. From f is equal to ke, we get e is equal to f over k, or e is equal to f multiplied by 1 over k. In this form, y is equal to mx plus c, e is equal to f 1 over k. With y is equal to e, x is equal to f, m, the slope, is equal to 1 over k, and c is still 0. So after calculating the slope from the graph, you can find k by taking the inverse of the slope. Let's take another example to understand how equations are transformed into a linear form for plotting straight line graphs. Consider the equation t is equal to 2 pi L over g square root from simple harmonic motion. Here t, the time period, and L, the length, are the variables. Y2 and g are constant. If we plot t directly against L, the graph will not be a straight line. To obtain a straight line graph, we must transform the equation into a linear form. First, we square both sides of the equation. T squared is equal to 4 pi square L over g. Rewriting, t squared is equal to 4 pi square over g L. This equation is now identical in this form to y is equal to mx plus c, with y equal to t squared, x equal to L, m, the slope, equal to 4 pi square over g, and c is equal to 0. So a graph of t squared against L will give a straight line passing through the origin, and the slope can be used to determine the value of g. For a graph of L against t squared, from the same equation t squared is equal to 4 pi square L over g, we can rearrange to make L the subject formula. Cross multiplying, 4 pi square L is equal to gt squared. L is equal to g over 4 pi square t square. Again, this is in the form y is equal to mx plus c, where y is equal to L, x is equal to t square, m, slope or gradient, is equal to g over 4 pi square, and c is equal to 0. Let's take a third example. From the relation v is equal to E minus IR, the equation relating the current I in a circuit to the EMF E of a cell, where big R is the external resistance and small r is the internal resistance of the cell. For a graph of V against I, by comparison, y is equal to V, x is equal to I. The slope or gradient m is equal to minus r. Intercept on v-axis c is equal to E, the EMF of the cell. Therefore, a graph of V against I is a straight line with a negative slope or gradient, which is equal to the internal resistance r, and v-axis intercept equal to EMF E of the cell. Although the equation may be rearranged to make I the subject formula, this form is not suitable for determining the internal resistance directly. Hence, plotting V against I is the appropriate method for this experiment. Here is a table of conversion of some equation of physics to straight line form. The equation, the two variables, the transformed equation, the y equivalent, the x equivalent, the m equivalent, and the c equivalent. Hope you've now gained clarity on how to transform physics formulas into straight line form, so that in an experiment you should be able to correctly interpret the gradient or slope and the intercept from your graph, and hence determine the required physical quantities for the experiment. Thanks for watching. Keep learning.